Well, we're back again, folks, and much sooner than Dylan and I had expected. I'm going to have to make an addition to my last video, which was titled A Solenoid Walking Beam Electric Motor. Unfortunately, right after I completed shooting the video, my motor failed. It stopped operating. Yes, I know that's hard to believe, because everything I build to industrial strength. However, there was a problem. Now, the motor only had two electrical parts. It had the solenoid and it had the switch that operated the solenoid. So which one do you think failed? Well, it was the switch. I selected the wrong part. And so you don't make the same mistake, I'm going to show you how I solved the problem. Here goes. Here's the switch I began using, the one that failed. It's a micro switch with kind of a long lever. Now the trouble with the micro switch is it's not rated for continuous heavy duty. It won't stand up to the punishment given to it by the solenoid motor. These are generally rated for low voltage and very low current. So this was not the right switch for my motor. Well, I was at a complete loss. I had no idea what kind of switch to use. What kind of switch would stand up to this kind of punishment? And then I remembered somewhere reading about something called a reed switch. A reed switch. Well, I had never seen a reed switch, never used one, had no idea what it was. But being a former musician, I wondered, is it a single reed or a double reed? Well, I looked into it. Turns out to be a double reed. There are two metal strips, like reeds, that come into contact with each other and close the circuit when they're exposed to an external magnetic force. When a magnet comes near the reed switch, it closes and completes the circuit. Now the nice part about the reed switch is there are no moving parts, or very few moving parts. There's no friction involved, and it's supposed to last forever. This is exactly what I needed for my solenoid motor. Here is a reed switch, and it's a perfect choice for my application. It's two pieces of metal resembling reeds that are encased in a glass tube. When the tube is brought near a magnetic field, the two pieces of metal, the two reeds, contact each other and complete the circuit. Here's how it works. I hope you can hear my fluke indicating continuity. And here you see the new setup. Here's my reed switch. It's just secured with a piece of electrical tape, and it's in about the same position as the micro switch used to be. This is the same angle bracket I had attached to my flywheel shaft before, but I've added two magnets to activate the reed switch. When the magnets come around to this position, the reed switch closes and charges the solenoid. If I turn the magnets around and listen very carefully, I can actually hear the reed switch make a little click when the magnets are in this position. This is useful in setting up timing. Perfection at last. My motor can run continuously and not have any switch problems. Now there's one thing to watch out for when you're looking for your reed switch. Most reed switches are designed to work at very low voltages with very low current. And because I'm charging a solenoid, I wanted to have a really hefty reed switch. I found one on eBay that is rated at 2 amps. And this was absolutely perfect, just what I was looking for. And it wasn't that expensive. Well, that's it for now. That's my addition to a previous video. I thank you for watching. And my partner, Mr. Dillon, thanks you for watching. We'll see you again next time.